All right, so for this week, we are going back to, as I'm calling it, the traditional bookwork. All right, so you should be reading your textbook. We're going to be working on chapter 2 this week, and then we do have a little simulation and then a traditional quiz again for this. All right, so kind of going back to traditional bookwork from the office work that we've been doing, that we did last week, since we're alternating each week. All right, so let's go ahead and dive on into this. Here you have the operating systems for personal use. All right. And there is a lot going on here. So, operating systems, you hopefully have heard of most of these. All right. Windows, basically everyone that I know of has heard of. All right. Nothing too crazy going on there. All right. This is developed by Microsoft. All right. The book tells you, I believe, that the current version is Windows 10. All right. If you're even a little bit into the wonderful world of computers, or you bought a computer recently, you probably know that we're actually in Windows 11, not 10. All right. So this says Windows 10. 11 is actually the current version that we are in right now. All right. But you do need to make sure that when you're answering your questions in the quizzes and things, that if it asks you what the most recent version of Windows is, 10 is going to be the answer. All right. Now, Windows has changed a lot over the years. All right. It's been very kind of similar for the start bar at the very bottom. So you have that bar at the bottom where you have all your icons and things like that, with the button far left. All right, when we got to Windows 11 now, it actually centers it in the middle of your screen. All right, so it has definitely changed a good bit since then. Overall, it's estimated that 90% of personal computers are running some version of Windows. All right, that is a lot of computers. All right, this is also why Windows computers are the ones that get hacked the most, because someone says, well, if I'm going to write a virus or something, I want it to affect the most number of people possible. So the easiest thing I can do is write one for PC, because there's 90% of the operating systems are using it. Right? Does that mean there are no viruses on their alternative, which would be like Mac? Then no, there are still viruses out there. So you do need to be careful on your Macs and things like that. All right. Security has definitely gotten a lot better. Right? And the one thing I always question myself on is the security better because I'm older? Or is the security better because it's just built into the system now and it works a little bit better? And I don't have a perfect answer to that one. Right? It's just one of those questions that I always ask, and I haven't been able to figure out an answer. So please be careful when you're downloading files, especially if they're questionable files or websites or things like that. It doesn't really matter what operating system you're using, you can get viruses. Now, moving on, sorry, got a little off topic there. We're moving on to the wonderful world of Mac OS. All right, was developed by Apple. All right, so any of you guys or gals who are Apple fanboys, you know your Mac OS probably pretty darn well. Right? Again, the book says that the most recent version of Mac is Mojave, and I don't think that is actually correct. Let's find out. It's Sequoia Mac 15. All right. I don't know what Mojave was. I think it was 10 or something. So it's getting a little old, basically. But anyway, Mac. What did I just say? Sequoia was released on September 16th, 2024. So that is just like 10 days ago. All right. So Sequoia is the newest version. I spelled that right, but hopefully y'all get the point. All right. Again, but when you're answering these questions on the tests or quizzes, make sure that you're answering them based on the book information, not the information that's necessarily up to date, because the book doesn't always have the most up to date information. All right. And one thing that I haven't talked about, Windows is available on laptops, tablets, desktops, all-in-one smartphones. All right, so it covers basically all your gamuts. All right, Mac is really only available on laptops, desktops, and all-in-ones. All right, they don't have tablets for that. They don't have smartphones for Mac. All right, now you do know that Mac does, or Apple does have an operating system for mobile units, and that will be iOS. All right, so that is right here next to that. So iOS is it's the Apple operating system for tablets, iPhones, and iPod touches. All right. One of the big differences, and I've heard a lot of people complain about this, is Mac OS for computers does not support touchscreens. All right. It is just one of those things. If you need an Apple device with a touchscreen, you are relying on an iOS-based device, so a tablet or something. So if you really want a touchscreen laptop, you can't have a Mac. That's what it comes down to. And I know a lot of people dislike that. Personally, if you ever use a laptop that has a touchscreen on it, even if it doesn't fold around all crazy to like the 2-in-1 or whatever, it's just a normal laptop, and that touchscreen makes a huge difference for usability. It's so much quicker to touch, quicker to touch the screen and things, and sometimes use a trackpad to try to navigate around. So I think that's something that Apple's kind of missing the beat for, but it's still there. All right. So Mac has a pretty decent use case for their computers. All right. And Macs tend to be more expensive for what they do. All right. So if you look at the pure performance of something, a Mac is traditionally going to be more expensive than a PC. But Macs also hold their value better, and they are a very quality computer. So yes, you could buy a really cheap Acer that technically has more processing power and whatnot, but it might not have enough cooling compared to the Mac or something like that. So it's hard to compare computer to computer, especially when you're comparing different operating systems. So something just to kind of be aware of. Another operating system is we have Linux or Unix and Linux. All right, they're not the same, but they're pretty darn close. All right, Unix was an early operating system. It features a command line, interfacing, and multitasking, and it's primarily installed on workstations and services. All right, Linux was designed to be similar to Unix. All right, it's traditionally an open source operating system with the code available to anyone who would like to develop the distributions and other various features like that. So it's really kind of nice. All right, it's also normally free because it's that open source. All right, we do have what's called distributions or distros, which include the operating system, various utilities, and software applications. Fedora is a very popular distribution right now. Mint, Ubuntu. There's a whole lot more. If you're getting into the server world, Proxmox might be a good one. So there's a lot of options when it comes to Linux. All right. While Linux is a very broad category, it includes a whole bunch of smaller operating systems or distributions. So it is definitely something to look into. And again, it does support laptops, desktops, touch tablets, all-in-ones. One big benefit to Linux is traditionally it's a lighter weight operating system, which means older hardware tends to work just fine with it. So if you have an old laptop running around and you're like, I really wish I could still use this thing for blah, 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 there's a good chance that you could. You just have to try Linux on it and find one that has a lower operating capability. Right? So Linux, another big one. Another operating system that is taken the market by storm over the last few years are Chrome OS. All right, and this is a web-based OS. Virtually no files are installed on your computer device. Everything is basically your computer is accessing the internet to do everything. All right, which is fine, right? If all you do on your computer is read your email, write a few Word documents and things, watch YouTube, browse the internet, Facebook, Instagram, Twitter, or X, or whatever, Chrome OS perfectly fine, perfectly capable for you, and they're traditionally very inexpensive compared to a full-blown Windows or Apple computer. And it all comes down to what you're used to. All right, Chrome OS is the biggest use is actually for education right now. And because of that, it's because it's a cheaper device. They're normally traditionally lower powered, but you can get very powerful configurations if you need them. But it also does, Google does give you the option to do a lot of control with them. So you can have an IT controlling all the laptops in the school remotely and things like that for checking things or uninstalling or installing software or whatever the case is. So Chromebooks are very powerful. All right, and Google was actually kind of brilliant with this. They basically said, we want to make this operating system and we want to make it very inexpensive for schools to get into this. Because now that they've gotten into the schools, when you graduate from high school or whatever, and you've used these Chrome OS things and stuff like that, you are now used to it. So when you go into the real world, your IT department's like, what type of computer do you want? If they won't give you a specialty one or whatever, you're just like, I just need a Chromebook. Don't need anything special. All right. So it's definitely a big market, that Chrome OS, and it'll be really interesting to see in 10, 15 years what has happened to it. Is it still just education, or has large companies actually started implementing it? So it'll be interesting to see. All right. And the last one that I haven't talked about on the screen is Android. All right. Android is the Google operating system for mobile things. All right. It is designed for smartphones and tablets. All right. So it's the equivalent of iOS, but it's Google. All right, it's a lot more open, not open source, but it is open, so you can configure everything to your heart's desire within reason. All right, where compared to Apple, it's like Google's like, oh, you want to change the text color on the taskbar? It's like you can download an app for that, or Apple's like, no, you're not allowed to do that. All right, I think it was just recently that Apple made it so you can move folders around off the home screen or something. not really a big Apple person. So there's been a lot of weird things at Apple. It's like, why wouldn't you do that? All right. Now, part of having that operating system, we need to have parts for your computer. All right. So I'm just going to quickly circle these, and we'll get into more detail in a minute. Oh, hey, it's supposed to be my pen still. All right. Anyway, so we've got our CPU right here in the middle. All right, that is underneath that fan. All right. That CPU is sitting on the motherboard. All right, so that would be this big device right here. And again, we'll come back to this in a minute, probably hit all these up. On the motherboard, you've got your RAM, which are these pink sticks right there. All right, you have some sort of storage. All right, so we do have storage over here on the right. We've got 2 different hard drives. All right, and you might have some storage built right onto the motherboard. Again, come back to that one. You're going to have some sort of GPU, which is traditionally the top slot, so that's probably that one right there. You're going to have a power supply. In this case, it's a 520 watt. We have cooling. All right, so you can see we've got some fans in the back. I think there's a fan right here in the front. There's a fan on the top. There's a fan on that CPU block. All right, and they've got other peripheral devices, which aren't really shown here. All right. Now, going back to CPU, that is your central processing unit. All right, it has basically 4 tasks that it does. It does input, then it does processing, then output, and then storage, and then repeat. All right, so it's just constantly doing that same thing over and over and over again. All right, so it's taking inputs, it's processing that inputs, and then it's outputting them somehow, and sometimes it saves those to storage. All right, to help do that, we have our decode unit, or not our decode unit, sorry, our control unit, and that coordinates the movement of data through the CPU. We also have the arithmetic logic unit, which performs arithmetic and logic calculations. It's crazy how that works out. All right. So here is the instruction cycle, and this is over on the right-hand side here. So we start with the fetch. All right. So we're starting down here in the blue. All right. So this retrieves instruction from the memory. So RAM, whatever the case. Then we go through decode, which is our control unit. And then we continue through execute, so the arithmetic and logic. And then we go back to storing, putting it into RAM. All right. Now, you just heard me a minute ago saying that we have storage on these, and I was pointing to some hard drives. All right. So RAM is basically a small hard drive for your computer. All right. Now, it is traditionally small. Personally, if you're buying any computer today or the next probably few years, you want a minimum of 8 gigs of RAM. And if possible, if you think that thing's going to last you a while, you probably want to bump that up to 16 just to be safe. All right. Especially with newer laptops and things, you don't have that option to not do that. All right. But so RAM is a smaller hard drive. All right. It's also extremely fast. All right. Now, for CPUs, they are measured with, one of the things they're measured with is clock speed. All right. And they are measured in hertz, which is times per second. All right. Traditionally, we're measuring CPUs in gigahertz, so it might be like 3.9 gigahertz per second or something like that. Or gigahertz is how many of the processing speed. To go along with clock speed, we also have cores. We're going to skip flops for a second. So cores is the number of processing units that we have. All right, we are approaching, 6 or 8 being the standard number of cores on a computer. All right? Way back in 2003, somewhere around there, I bought a laptop that had a single core 2.4 gigahertz processor. All right, when I went to college, 4 years later or whatever. I had a desktop, not a laptop, that had a quad-core 2.4 gigahertz processor. All right, so I quadrupled the amount of processing power in my computer in those 4 years, which to me is absolutely crazy. All right, and we're also getting nowadays with the higher Intel computer chipsets, you have efficiency cores and you have P cores, which are the power cores. So when things don't need to be super powerful, they use the efficiency cores, the E cores, and when they need a lot of power, then they turn the processing of the power cores on to do that processing. So it's really getting kind of interesting. All right, Intel and AMD are the 2 big names in computers right now for processors, but we're also slowly moving away from that. Apple actually doesn't use Intel or AMD anymore. I forget what they're using, but they're using a custom chipset that they've kind of worked with themselves. All right. To go with continue with cores, we go to hyperthreading, and that basically enables your single CPU to appear as 2 CPUs. This allows your computer to help prep information a little bit faster, so that way if one of those cores does finish something early, they are able to kind of like move on with that. All right. Sometimes hyper-threading is helpful, sometimes it isn't. All right, it just really comes down to the situation and the software that you're using. So now we can go back up to flops. All right, this is your floating point operations per second. This is used for supercomputers. All right, so we're not really dealing with supercomputers, but that is how they're measured, and they're measured in petaflops, which is 10 to the 15th. All right, so that's a lot of things. All right, we also have pipelining, which improves the speed of a single processor. All right. Think of this like an assembly line where each step of the instruction happens simultaneously. So when decoding starts for one process, fetch starts for another. All right. So we're trying to keep these things moving as quick as possible. Now with your CPU, you do need to have some sort of heatsink, some sort of cooling. All right. As we saw in that last picture, those just little fans sitting on the desktop. All right. We're going to come back to cooling in a moment. And your CPU may have a GPU built into it. Again, kind of might talk about that in a few minutes. So cooling here, all right? The whole point of cooling your computer is to move heat away from your components. Your CPU and your GPU are the two biggest heat generation units in there, all right? So over here on the right, I have a rather large air cooler. All right, this would definitely be overall, I'd say, for like a top-end processor. It is just basically, we have a copper at the bottom heat block with some heat pipes that bring the heat up into all these little fins, and then we have air fans that blow cool air across those to take the heat away. All right, so that is an air-cooled system. We do also have water-cooled. All right, so here we actually have a pump, and then inside these tubes is water. So instead of using air to transfer the heat directly away from the CPU, we're taking the heat away in the water, which then goes through a radiator in the back, which spreads that water out over a very large area, and then we have fans blowing across that. So even though this is a water-cooled system right here, so it's called an all-in-one, an AIO, it still does use air to remove the heat actually from the system. It's just before we do that, we're taking the heat away from the components with water. All right, and the benefit of that is it's easier to transfer the heat to the water than it is to the air, so you can move a lot more heat away from a component that way. AIOs or custom water loops aren't actually necessarily any better than a good air cooler, right? So you have to play that game, all right? And anytime we're dealing with case fans, all right, we have lots of different comparisons. 120, I would say right here, this is, I'm going to call it the gold standard. This is the one that basically most computers are using, all right? Sometimes you'll see 140 or 200 millimeter. Sometimes you'll see the smaller 80, all right? It just really comes down to the size of the case that you're using and things like that. So the 120 is probably the most used one out there. All right. And when it comes to your case fans, you've got three different options. You have positive, negative, or balanced pressure. So in a positive pressure system, you are having all of your fans pointing into your case, which sucks all the air it can, shoves it into the case, which makes it a higher pressure inside that case. And then the air leaks through whatever random holes it can find in your case, any way it can escape. In a negative, it's the exact opposite. So you have all the fans pulling air out of the system, and all the air has to find any random hole it can in the case. All right. And the last one is balanced, where you have like one fan pointing in, one fan pointing out, or two fans in, two fans out. So in theory, you're directing airflow through your case now. Preference, I don't know if there's truly a good preference or a good difference there. I think the biggest difference is with dust and things like that, where with like negative pressure, you're pulling all your dust in through all your holes, which might not have filters on them. So positive pressure is sometimes the better option, or balanced. So, but it's one of those things that you need to kind of like play around with and test. All right. So here we have a motherboard. All right. So we've got a lot going on here. So we have our CPU socket, which is over here underneath this thing. That is our cooler for our processor on this board. All right. We have PCI expansion slots. All right. Those are down here on the left. There are these little blue pieces and actually this white one. And if you notice, there are different connectors there. So there are PCI, there's different generations, there's different number of channels or lanes that you're using. All right. So this white one is I think it's a PCI 16x1, and the blue one is a 16x8 or 16x16 or along those lines. Sorry. But anyway, so it's not PCI 16. It's a PCI Express by 1 or by 16. So the blue would be by 16, the white would be Y1. It could be by 8 too. It really just depends on how the motherboard's set up and things like that. All right. So that's that. We got our RAM slots over here. All right. This one you can see has two different channels. All right. We're using channel 1, and there is a channel right next to that that's not being used right now. All right. Really, you want to use every RAM slot on that motherboard that you can. It really is the best option for you. Now, if there's 2 channels, if there's 4 slots, sometimes only using 2 is the best option. It really comes down to the situation and future-proofing, I think. On newer laptops and stuff, the CPUs and the RAM and everything is starting to be soldered directly to that board, so you can't update it. This is why I said earlier with laptops, that's like you want to update, you want to put as much in there as you can at any given point. All right. We have our power. All right. So right here we have our main 24-pin power header. It's that blue one. All right. That is our main one, and there also is traditionally going to be another one up here by the CPU. All right. Now this one might be old enough; it might not have it. But it's also another 4 or an 8-pin connector up there for more 12-volt power to supply enough energy to that CPU is what it comes down to. So that really comes down to what's going on there. We have our SATA drive controllers. All right, these are these blue connectors down in the bottom corner there. All right. This one has 4 to it. We also used to have IDE, which would be much bigger connectors. They were, something like this, and they had a little key there with a whole boatload of pins going on in here. All right. So yeah, just kind of something to be aware of. We also are moving on to M.2, which is just like a big flat spot on the motherboard. I think I show you that later in this little presentation. So we have our I/O in the back here. All right, so this whole section, that is all of our I/O. We can't see that very well right now, but that's what's going on the back there. We also, if you notice, there are a whole bunch of headers. Random pins just sticking off all over the place on this thing. All right, those headers could be for USB 2, they could be used for USB 3, they could be for the panel connectors on the front, like the power button and lights that are on the front of your case, or the USB ports on the front of your case. There's a whole lot of different options that's going on there. So just kind of something that you do need to be aware of. All right. Now, as part of your motherboard, you have your BIOS, and this is your basic input-output system. The BIOS on the motherboard is read-only memory, is stored in read-only memory, I should say, or ROMs for short. It is non-volatile and is used to start the basic operations of a computer when you switch it on. All right. What non-volatile memory means is it does not require power to keep the data. All right. And one of the first things you do when you turn your computer on is it does a post test, which is a power on self test, and this tests and initializes the hardware and begins to load the operating system. All right. Now, as part of that post or your BIOS, you do have what's called CMOS, which is complementary metal oxide semiconductor. And this is where we store settings for the BIOS to use. All right. These are volatile memory, so that means it does need a battery or something to keep the memory stored there when the computer is off. I believe kind of like right in the middle here is the battery on this motherboard. It's just a little coin cell, normally a 2032. All right. So it's just kind of something that you do need to be aware of. All right. Here we go. I got everything going on here. Anyway, so again, you can kind of see all of our sockets over here on the right here. All right, you can see our PCI Express, PCI Express, PCI. Here's your RAM again, your power, your one power connector. Here's another power connector. Didn't talk about this, but there's a bunch of fan connectors. All right, so there's a lot going on motherboards. It's really what it comes down to. All right, motherboard ports. There are a lot of them. All right, this is going to be what I'm going to call it a fancier motherboard. All right. It is missing the PS2 connector, which is I'm going to call basically like the standard connector that we used to use before USB. So when your computer has problems, if you have a PS2 connector and you have any keyboard or mouse issues, I would try that connector. This one doesn't have it. It is like a kind of like a circular connector with like a flat top on it. And again, there's like, I don't know, 12 pins or something inside of it. But anyway, we do have USB. All right, so you notice that there's a whole bunch of different. Didn't go around that one. Whole bunch of different USB options on here. All right, I believe these are all 3 and maybe even 4, Gen 3 or Gen 4. All right, connections. All right, the biggest way you can tell the difference normally is Gen 3 is normally blue. All right, Gen 1 or the red one here they're showing you as being 10 gig capable. All right, that's why they're a different color. So there's a lot of USB on this board. We do sometimes have optical audio out, which would be this SPDIF. All right, so we sometimes will have optical audio. This one does have HDMI built onto it. Not all motherboards have HDMI or Ethernet or VGA or DVI or whatever the case is. All right. Some don't have motherboard GPUs built onto the CPU, so you don't have a need for having that. So a little give and take. We do have 2 Ethernets in this case. We have a 5 gig and I'm assuming a single gig connection. Not too crazy there. We have a whole bunch of audio connections over here at the far right. All right, and this one's nice. It actually tells you this is your rear, line in, line out, mic in, your subwoofer. All right, so it actually is telling you what they are, which normally they're color coded. So like green is your traditional speaker output. This one does have wireless antennas built onto it, which is nice. So you have Wi-Fi built right onto this motherboard. Not all of them are going to have that. Other things that you might see would be FireWire, although to me, I haven't seen that one around in a long time. All right, you might see DisplayPort, which kind of looks like HDMI port, except for it's just got one end squared off on it. It's kind of like that. Again, VGA, something else you might see. DVI, so VGA is traditionally blue, DVI is traditionally white. You might see USB-C, which we do have here. All right, and so the USB-C has kind of become the catch-all. It does a whole lot of things, so you need to be careful what your USB-C ports are capable of doing. All right, when we come back to USB, here you can just see we've got USB 2, 3, super speed, and then we're all over the place. So USB 2, this is, again, your traditional USB port. All right, you got like a little thing in there. Then you use super speed, we got Gen 3, 3.2, 3.1, 3. I mean, it's the naming scheme for USB needs to be redone. It's really what it comes down to, in my opinion. So just kind of something to be aware of. All right. Then we come back to our RAM. All right, RAM is volatile, and if you remember a minute ago, I just told you that volatile means that it will forget if you turn power off to it. So every time you turn your computer off, RAM gets basically erased. All right. We do have DIMM and SODIMM. So DIMM is dual inline memory module. SODIMM is small outline dual inline memory module. Traditionally, SODIMM is on laptops. All right. I also told you a minute ago that they're now starting to solder the chips for RAM right to the laptops instead of having these actual boards that you can put in and out, which means you can't upgrade them at all. It's a size thing is what it comes down to. So something just to kind of be aware of. All right. We also do have DDR, or not DDR. We don't have it. RAM is normally measured by types of DDR, which is double data rate. We are up to generation 5 right now. So if you're going to buy new RAM for your computer and it does have slots, just make sure you're buying the right type of RAM. That's really what it comes down to. RAM has some cache memory, which stores frequently accessed information. It works at a fast speed than other types of memory. We typically place this as close to the processor, so the data and processing time is reduced, increasing our performance. All right. And here is a comparison of the different DDRs. So here you have 2, 3, and 4. All right, and the big difference is, for your purposes, is where this notch is. All the pins are, going to be slightly different, but the big thing here is that they did put this notch in different places, so that way you don't have. In theory, you can't accidentally install DDR RAM into a DDR4 board. Now, if we look at this, there's not a lot of difference between this line and this line, all right? So you don't want to try too hard, but if you also do look, there's a lot more connections on this one than there are on that one, all right? So it's just, again, something to be kind of aware of, all right? Now, you may be asking, all right, you told me that I should have at least 8 gigs of RAM. How do I know I need that much? Well, here's a nice little example for you. So if you're going to run Windows 10, you need 2 gigabytes for that. And then if you're going to have Office open, you need another 2 gigs. And you're also going to have web browser open, in this case Edge, that's another gig. You might have some music playing in your iTunes in the background, that needs another 2 gigs. And then you're also doing some Photoshop, so that's 4 gigs. So you would need, in theory, a total of 11 gigs of RAM to run all those programs simultaneously. All right. This is why I'm like, yeah, if you can get 16 at this point in my life, I would push for the 16. All right. Is it a perfect system? No. All right, but it is definitely kind of a handy one to have. So if you can get that more RAM, I would probably splurge for it. You probably aren't going to regret spending the extra money. Now, the one thing I will say is sometimes, especially on like desktops and laptops that have removable RAM, it may be cheaper to buy the lower end model and then buy new RAM and add it to there, or double your capacity, whatever the case is. So, when it's like, when Dell's like, hey, we'll upgrade your RAM for $300, and you're like, only $100 for this 2 sticks. Why is it $300? Right? And it is very easy to install. So I believe in basically all of your capabilities to install RAM in the long run. All right. So we have keyboards, and there are a whole lot of different types. So we have QWERTY, which the whole point here was to reduce the number of key jams on a typewriter, spreading the letters out. All right. So they took the letters that we use the most often and spread those out, so that way we would have less likely of the arms colliding with each other with a typewriter. All right. In theory, this is not the best system. All right. We have our home row, right? In theory, we rest our index fingers on F and J. All right. So that'd be F and J. All right. If we would come right up, that would be U and H up here on the Dvorak option. All right. And this places the most commonly used letters where they are most easily accessible. So right there on that middle row, you can see that 70% of the keys are on that middle row now that we're going to use most frequently. 22% are on the top, 8 are on the bottom. All right, and this is done to reduce fatigue on your hands. All right. Now we also have some ergonomic keyboards. All right. They have curved shaped hole that helps keep your wrists in a more natural position, which helps reduce your wrist strain. All right, and up so at the bottom, I have a really curved one. It's really easy to see. At the top, it is curved. It's kind of harder. It's also split, which means you don't have to have your hands really nice and close together. You can kind of pick how close your hands are. I've never used one of these types of keyboards. That'd be one of those things I'd always be interested in trying, but I haven't actually done it yet. We have can't go yet. So those are ergonomic keyboards. We do have keypads, which is just your number pad right off to the side. Normally you can go back. No, this doesn't show it. You can just barely see it on this one over here. So this one has a keypad on the side. I have just a straight up USB keypad on my desk here. All right. I use that mainly for switching things for my Zoom sessions. So that way I can press buttons and use it as shortcuts instead of having to do things. And personally, it makes sense to have the number pad on your left. If you're using your mouse in your right hand, your number pad should be on your left hand, not your right hand. You don't have to take your hand off the mouse to do number pad stuff. But hey, not my choice. We also do have modifier keys. These temporarily alter the primary use of the keys. So Control, Alt, Shift. If you're on a laptop, Function. All right. So those all change things, especially the Function button. You got to be kind of careful of that one, especially your F keys at the top on laptops. Normally, I think most laptops now default to being it uses the Function submenu for like volume up, brightness, whatever, Wi-Fi on and off, those types of things, compared to actually F1 through F12. So you have to be careful when you need to hold the Function key and when don't you. All right. We also do have toggle keys. So modifier keys are temporary, toggle keys are permanent. So permanent alters until you press it again. So a good example of this would be caps lock, number lock, scroll lock. All right, those types of things. So we also have pointing devices. All right, so we have mouses, we have trackpads, trackballs, touchscreens, interactive whiteboards. All right, it's all a little bit of a give and take. All right, so touchpads, built into laptops. You can get little USB ones if you want a little USB trackpad for something. Although I don't know who would want that other than something that's built in somewhere. All right, I guess I do have a little USB wireless keyboard that has a touchpad on the side of it. So that way, if you're sitting on a bed or a couch, you could use that to control your smart TV or whatever and have a full keyboard and a little touchpad instead of having to use a mouse or something. So it could definitely be handy. We have mice, and I have a different example of a mouse up here. All right. Personally, I love this type of mouse. It's a mouse I have at home. It's mainly used for gaming. All right. But as you can see on the side here, we have 12 programmable buttons. All right. So for me, like one of those buttons is play pause and volume up, volume down, next track. Enter grades information, all sorts of things can be programmed into using those. All right, and I have programmable things where I'm like doing my grading, and I'm like, okay, a lot of students I know get 100 on this assignment, so I wear a little macro stuff. I just press that button, and there's 100 for their grade for them, so I don't have to manually type it in every time. So it's a very convenient thing to be able to have those little macros that you can change what they do with the buttons and have really quick access to things. So definitely something to look into. All right. You also have the trackball option. All right. This one, in theory, is better for your hand and wrist because you don't have to move it around. You just use your thumb to spin that little ball around. All right. So it definitely takes a little getting used to. I had a student last year, I think it's a year ago, who actually bought one of these to use as instead of a normal mouse in the classroom because of the desks not liking traditional mice. And I think by the end, he actually kind of liked it. So kind of interesting to look into. We do have touch screens. All right, we're all used to those on our phones nowadays, and like everything is starting to have touch screens on them. There are two types of technology, with capacitive being the one that we use for most devices nowadays. This senses the conductivity properties of the object as a finger or a specially defined conductive stylus, or like a French fry, and it will also detect. And the other option would be resistive, and this is going to be our older technology. In this sense, it's actual pressure on the screen, and it like estimates where the center of that pressure is. So if you're trying to use something with gloves, like heavy gloves on, resistive is a better option. Now they do have gloves nowadays that have conductivity or capacitive based, like metal thread or something sewed into on the finger, so that way you can now actually touch capacitive things. All right. And last big one is going to be interactive whiteboards. All right, I actually have one in the classroom that I'm in right now. So it allows me to draw digitally on the whiteboard instead of having to draw on the whiteboard and erase things. I can actually save it and upload it or email it to people or whatever the case. So really kind of a handy device. We have cameras, all right, and cameras, there's a lot of different things here, all right. This is going to be your standard like point and shoot camera. All right, your standard point and shoot. All right, it's a little cheapy. All right, I don't know many people who are buying these anymore because for the most part, our phones are capable of doing this. All right, so we don't really need standard point and shoot cameras anymore. I would say your smartphone has overall replaced the point and shoot camera. Right. What smartphones trying to replace but never truly will be your DSLRs. All right, so the big professional level photography. There is so much more that these devices can do, and yes, Apple will try to convince you that you don't need a DSLR anymore. You can just use your iPhone. But I still don't think you're ever truly going to replace the DSLR for true photographers. The controls and the ease of use and all of that is there. All right, I actually have a DSLR, and when I go on like large trips and things like hiking and whatnot, even though I have this giant heavy carry camera around with me, I would much rather have that than my phone. All right, because it's the zoom capabilities and focusing and the effects that you can get with changing the aperture and things like that are just absolutely amazing. So in the long run, in my opinion, like the DSLRs have the capability to be a much better camera than your standard smartphone camera. It doesn't mean they are, because it all comes down to who's operating the camera. So someone who's really good with a smartphone might be able to take better pictures, well, probably does, than someone who doesn't know how to use the DSLR correctly. So a little bit of give and take going on there. All right, we also have mirrorless cameras, which are trying to replace the DSLRs. So in the mirror, in here, there's actually a little, actually, I think I drew that the wrong way. I think it goes forward. So that way, when you're not taking a picture, the light comes in, hits up on this, bounces up and through a whole bunch of mirrors, and then comes out here. So you actually are seeing the actual image that's the camera seeing, unprocessed by anything. All right. And then when you take a picture, that little mirror there actually folds up out of the way. The light hits the sensor behind it, and then once after the designated time, it then folds that mirror back down. The light gets reflected back up again. All right. Mirrorless. They skip all those mirrors and things, and they just use that sensor to constantly show you a little screen up here, what's going on, so what the camera actually sees. So with digital cameras, we can start getting away from to get to these mirrorless things. All right. We have web cameras, which here we have a nice little Logitech one that is meant to get added to a laptop or a monitor or whatever the case is. All right. Webcams, obviously, you all probably have them built in. Super handy devices to have. They often have their microphone built into them, and video and things like that. I mean, that's what I'm recording this on. It's on a little Speedle 1080p webcam. Probably a little piece of junk webcam, but it gets the job done for me. All right. So webcams, oftentimes webcams on computers are junk, especially the ones that are built in. All right. These ones that you're adding could start getting a lot more capabilities. And some people are using HDMI to capture their web camera, so that way they get really high quality going on here. All right. Other things we've got are scanners. We've got optical scanners, which is what I have in the top right corner here. All right, so if you might have seen one of those around, or you might have one of those. All right. It's one of those things that it's super useful to have a scanner lying around your house if you can. All right. And they convert documents to digital files. Traditionally, they're going to save them as either a PDF or a JPEG. Sometimes you'll run OCR or optical character recognition on there because the text is not editable when you scan it. It's just a picture, basically. All right. We have two different options there. You have the bed feed option, which would be where like this thing would lift at this line, and you'd have just a big glass plate where you could put a piece of paper down and hit scan. Or you can have document feeders, which is what is on top of this one. So you put a pile of documents here and you hit scan and it sucks it through and it spits it out the bottom and it's scanning it that way. All right. So the automatic document feeders are definitely a nice thing to have. All right. We also have QR codes, all right, which is what I've got showing up here in the kind of the top middle of the screen. All right. There it is. So you can have QR codes, and just for funsies here, let me just scan this one and see what it is. I don't suggest you do that, but this one looks like it's going to take me to the HTC website. All right. Now, I will warn you that QR codes are not the most secure thing in the world because Other than you scanning it and looking at the URL or whatever information that it's providing, you don't know what it's trying to do. You don't know if it's trying to give your Wi-Fi or connect you to Wi-Fi or whatever the case is. So you do need to be kind of careful with QR codes. Okay? We also have RFID, radio frequency identification. And this is nice because we can read information without actually touching objects. Traditionally, this is going to be a one-way device. We have NFC, which is near-field communication. This is bi-direction, so we can, again, share data by touching devices or getting them close. All right. NFC is the symbol that you see on the right here. So if you're actually using your cell phone to tap and pay, that's NFC of sorts. And it's actually allowing you to say, oh, I want to use this credit card to this one. So it actually changes the information that it's sending, which is really quite nice. We have magnetic strip readers, which are just, that's what your card, if you were to actually swipe your credit card or ID or whatever, if you have that black bar on the back, magnetic strip readers are reading information stored on that via positive magnetic and not being not magnetic, right? And then the last type of scanner would be, like simple scanner would be biometric, all right? And this is the type of thing that many of us have on our phones, all right? So you put your finger on the fingerprint scanner and it says, oh, yep, that's you, and then unlocks the phone for you without you having to type a code in or anything like that, which is wonderful for ease of access as our phone and light layer security. But if all you need is a fingerprint, it's very easy to trick somebody or force someone to unlock their phone. So you do want to be careful with biometric devices. We have other input devices. We've got microphones, we've got game controllers, we've got adaptive devices for making it easier for people who have disabilities to play. We have voice recognition software. The list here just kind of goes on and on and on and on and on. We've got monitors, all right? And you might hear the term, oh, it's an LCD monitor and LED monitor, all right? They're basically the exact same thing. It's just what is backlighting it, all right? For the most part nowadays, everything is an LED monitor, all right? But before that, we had LCD monitors, which use the same technology. We just use a fluorescent light bulb in the back to light the screen up instead of LEDs, all right? Now, when you get to AMOLED or OLED, that's a whole different game than LED. So OLED is organic LED, and each pixel has its own backlight. And so the blacks are very blacks. You also have that's an AMOLED, which have an active matrix OLED, so they are sharper and have wider viewing angles than the LCD. So they still have individual backlights. Basically, every pixel is its own backlight, but it gets you better viewing angles. And then for projectors, go back. Here we go. For projectors, we've got DLP, which is digital light processing. And there's just tiny swiveling mirrors to create the image, or you have LCD projector, which passes light through the prism that divides the light into 3 color beams, red, green, and blue. And the beams pass through LCD screens, and then that's how it gets projected. All right, so there's a lot going on here. All right, and one of the big things you need to think about anytime you're looking at any sort of screen, whether it's a projector, a monitor, your cell phone screen, whatever, is the nits of brightness. Nits, N-I-T-S. And that's basically saying how much light can come out of that screen at any given moment. All right. And that's what allows you to see things in bright sunlight or whatnot. So nits is a very important thing. Now, when it comes to GPU, all right, we've got a few options going on here. So as I mentioned earlier, you can have your CPU and your GPU built into one thing. So your CPU is doing all the heavy processing. So you can see all the CPU load is the orange and the yellow is the GPU load. And we are using up, we're not going very fast. All right. Or you can have a dedicated one, which is what I have over here on the side. This is a EVGA GeForce RTX 3090. All right, I believe we're up to 4090 series, or 4090 is like the top of the card right now. It's also a really expensive card, but this is going to be a dedicated graphics card, which is going to allow you to go a lot better processing of video signals and things like that. So a little give and take going on there when it comes to your GPU. Dedicated is always going to be better. You have to find that sweet zone, especially on mobile applications. Battery life is very important. Dedicated GPUs use a lot more energy, so it doesn't make sense. They also need a lot more cooling because they're going to be using a lot of energy. So it doesn't always make sense to have a top-of-the-line GPU in a laptop. Now here we've got port examples for video outputs. All right. So we've already kind of briefly talked about HDMI and DisplayPort. All right. There is also Mini DisplayPort over here. All right, which is just a smaller version of DisplayPort, which is nice. We have VGA, which is kind of like the old standard nowadays. DVI and dual link DVI, they're the same thing, but you notice there's a slight difference here. All right, that's because this one does analog, I believe. So you could actually pull VGA off of this, where this one is digital only, but it allows you to, I believe, do 2 screens, if I remember correctly. So there's a lot going on there when it comes to DVI. And DVI is basically the exact same thing as HDMI. The only difference is HDMI has audio as part of it. Right? So it's a little bit of a give and take going on there. And also USB-C now is starting to be used for display ports as well, which is kind of crazy. We've got audio outputs, so we've got speakers. Okay, probably hopefully you're all used to speakers. Right? We've got headphones, lots of different options there. Noise canceling is starting to become a big thing nowadays. This reduces the effect of ambient noise. You can have real big headphones that have them in there, or you can have really small little earbuds that have noise canceling built in. So it really comes down to what you're trying to do. Okay? We also have headsets, which traditionally have a microphone of some sort built into them. And then your sound card. This is what's going to provide audio to your wired connections. Higher end cards can handle up to 8 speakers. Again, a lot of desktop motherboards, you can do at least 6 speakers, or at least like 4.1. So your front speakers, back speakers, and a subwoofer or something like that, all having their own dedicated plug. This setup here in the top right, this top right one, that is probably a single 3.5 millimeter plug. That's the green one. So it then takes that and subdivides it into the base and the 2 stereo speakers for you, so you don't have to use all the secondary things. So it really comes down to personal preference on that one. What do you want? How you want to wire things up? Printers. Ooh, there are a lot of different options here. All right, and the big one I have here is what's called a 3-dimensional printer, a 3D printer. All right. So this is basically a hot glue gun that's CNC controlled, so it can extrude or squeeze out plastic that's melted and draw lines on the bed, and then it just keeps doing that and keeps doing that until you have a 3-dimensional shape, because it just slowly builds it up layer by layer, and that can take a lot of time. All right. So they are really cool, but we really aren't at mass market acceptability yet, because there is always tinkering that is involved with these. Very rarely do you have a 3D printer that is set and forget, where you just click print and you can walk away and basically guarantee that you'll have a successful print the next day. It's not really something that we're doing anymore. So it's annoying, but it's definitely something that's out there. All right. Most people, they're going to have inkjets at home. All right. That's that traditional one where you put the little cartridges in of the red ink, a green ink, and a blue ink, and they're small, and the ink is really expensive. The printer, really cheap, but the ink, really expensive. All right. Personally, if you can swing it, I would do a laser printer. All right. They print a lot more off of both a single tonal cartridge. And another nice thing about laser printers is the toner doesn't go bad. All right. Inkjets, the ink can dry up over time, so you actually need to actively, consistently use those. Where the toner with the laser, they just kind of keep working, which is really, really nice. All right. So laser printers, if you can swing it, the black and white aren't horribly expensive. If you want color, it's got a little bit more expense to it, but it'll probably save yourself a lot in the 10 years, whatever that you own the thing, of not having to constantly buy ink because it dried out or whatever the case is. So just kind of something to be aware of. We do have all-in-one printers, which are printers with fax machines and scanners and printers all built into them. All right, so a little give and take. Personally, thermal printer is one of my favorite. All right. Anytime you guys get a receipt from a store that's printed out right there in front of you on like the 3-inch wide paper, all right, those are actually thermal printers. All right, a fun thing that you can do with them, you have to be careful, but if you take a heat source and you heat up the paper, you'll actually see the whole paper go black. So if you have a hair dryer or a heat gun, or if you're really careful, you can use a lighter and you can just carefully move the heat around on the back, and you'll just start seeing the whole paper go black because it's thermal based. All right. And that's how they keep themselves from having these inkjet issues or laser issues of printing, and keep the printer at small size. So that one's really cool. Photo printers can be used as inkjet or dye sublimation technology, and will often connect directly to a camera for the transfer of photos. So printing directly off your photo printer. Dye sublimation printers use heat to turn solid dye into a gas that is transferred to the special paper. Most often, it's specialty printer limited to photo printing and other specialty applications. So again, really neat technology. Dye sublimation, you can kind of print on anything because of how the process works. As long as you can get your printer to lay down the solid dye onto the item, you can kind of print on it, which is, again, really kind of neat. All right. For communication devices, we've got analog versus digital. All right. If any of you guys are using Comcast, coax for your home internet, you've got that, big circular cable running into your house into a modem. That is an analog communication device. So that modem, it takes analog and converts it to digital, and digital and converts it back to analog. So that would be your analog. Ethernet is going to be digital. Wireless is digital. I already talked about your modem, what it does. All right. Nowadays, a lot of people are starting to have fiber optics run to their house. So that is a digital-to-digital system. All right, so a lot more speed with fiber optics and coax, and that's just the limitation of how coax works and how they've decided to make it work. So, kind of decisions that were made way back when that are still being used, and doesn't really make as much sense today, but they're kind of just sticking with it. Where fiber optic is the new kid in town, and they're changing up the system. So, it's really nice if you can have fiber running to your house for whatever cases for internet. All right. When it comes to wireless, we have old 2.4 gigahertz Wi-Fi speeds, and then we have 5 gigahertz. All right. And I do have theoretical speeds and actual real-world speeds. So you can see with 2.4 gigahertz, technically we could get up to 150 megabits per second. All right. With 802.11n, notice that we can go up 450, and AC we can go up to gigabit over wireless. All right, which is absolutely amazing. Now that is limited in distance and things like that. So wireless can be as fast as Ethernet nowadays, which is really nice. All right. We also do a wireless we have 6 gigahertz now for wireless as well. So a lot going on there. And then fax, convert paper documents to digital and send it over telephone wires, but typically printed. So faxes, I don't know the last time I've sent a fax. It's been a very long time. We've kind of hit up all these peripherals already. Storage disks, all right, for external storage. We have, there are hard drive based stuff. So, you could have a portable hard drive that you plug into your computer. Traditionally, that's going to be over USB. It could be over external SATA, but traditionally USB is the way. Maybe Thunderbolt nowadays for speed. Right? We also have flash-based storage. So you can probably all are used to seeing a little micro SD card slot. We have full SD. We also have this compact flash card there. All right. So you need to be kind of careful with your external storage and which one you're getting. And one of the big things you need to know is how fast is the read-write of that SD card that you're using. So you want to make sure that you get something that is capable of doing what you want. All right. Just for funsies here, I still have CDs, DVDs, and Blu-rays on here. Not seeing those a whole lot anymore. All right, but you might have a CD, DVD, Blu-ray writer, reader, whatever. So you might have read-only, you might have recordable, you might have rewritable. All right. And for fun, CDs, they hold about 700 megabytes. DVD single layers hold about 4.7, double layer 8.5, and Blu-ray singles 25 gig, and Blu-ray double is 50 gig. So Blu-rays hold a lot more information than DVDs, and I think it comes down to the laser diameter that's writing the information on the discs themselves. So kind of crazy when you think about that. For internal storage, here we've got our nice kind of progression of where we came from. So we have the traditional spinning hard drive. Some people call these spinning rust because there is actually a middle disk in there that is spinning. All right. So you have a motor that makes that thing spin and writes the information and reads the information off of it. All right. This is going to traditionally have your highest capacities. And it's also the most capacity for the dollar. All right. The downside is these types of hard drives are slower than their solid state brethren. All right. So this would be, it's a 3.5 inch drive. All right. Traditionally, most solid SSDs are 2.5 inches. So they're the laptop size. They are solid state. They are completely flash-based storage, so there's no moving parts. They are less power hungry because of that, which also means they're quieter and cooler. So they kind of win in every form factor compared to the old traditional spinning hard drives. They're also much faster, so you can read information and write information off them in much quicker form. Right. Now we have moved to the M.2 form factor, which is this one on the far right here, M.2. All right, and there are two different versions. There's NVMe and SATA. All right, NVMe is much quicker than SATA, but I'd say the average person probably doesn't really truly realize that speed difference. All right, I think I could have two of the exact computers, one running off SATA, one running off NVMe, and you overall wouldn't really be able to tell the difference between which one was which. Although that would be a fun thing to test. All right. Some average speeds, just so you know, traditional hard drives, they're spinning at 7,200 RPMs, which gives you about a read-write speed of between 80 and 160 megabytes per second. The SATA SSDs, they have a read-write speed of about 550 megabytes per second, so over triple that of the traditional hard drive right next to it that has the spinning speed. And if we go to the NVMe drive, that is 3,500 megabytes per second, so that's 7 times faster. All right. Now, when you're talking about milliseconds, again, 7 times faster, I don't really think you're going to truly see. So, there's other things that are going to slow your computer down more than that reading. So, kind of interesting to look at. All right. So, yeah. And then I think this is just about the end. We have power supplies. All right, we have ratings, and that's the 80 plus. And there are 5 standards here. There's bronze, silver, gold, platinum, and titanium. All right. And here you can see a graph of how those compare. So if you are sitting at a 50% load, 80 plus is 80% efficient. Bronze is 85, silver is 88, gold is 90, and platinum 92, and titanium is 94. All right, so you can see as we go down, we get these higher levels, they are more efficient, and that's the whole point here. All right, if you have a computer that you're only going to use once in a while, having a super high-end power supply doesn't make a lot of sense. If you have something that you're going to be running like 24/7, having that more efficient power supply is going to save you money in the long run. So it might be worth getting that higher-end power supply. Right? And the other question here is, how big do you need? All right. And the answer to that is it's all based on the hardware in your computer. All right. I actually found out the hard way that my hard drive in my computer was failing. All right. It would work perfectly fine, and then it would randomly shut off on me. And then it would work perfectly fine after I rebooted it, and it would randomly shut off on me. And sometimes that random shut off would last 30 seconds into boot, and sometimes that random shut off would last 10 days. And what caused it was me having too many different devices on my computer running at the same time that the power supply wasn't able to handle that much load. I just kept adding hard drives and GPUs and things, and I just kept changing things and put newer, better things in or more things in, and I started using more power than my power supply could handle. So you do need to make sure that your power supply is capable of handling all of your devices. So you just look at the total wattage that your device might be using. So okay, my CPU is 200 watts rated, my motherboard needs 50 watts, my GPU is 400 watts. It's well, that's 640 watts, and you have some hard drives and things like that. So you're okay, maybe I need a 700 watt power supply or something. And you don't want to run it at 100% the whole time. You want to run it at a more acceptable 50, 75%. So you always want to overspec your power supply a little bit. And then most power supplies nowadays are coming in one of 3 options. You have modular, semi, and non-modular. So if we look at the modular, everything on here, there's no wires sticking out, there's just ports on the back. So you have, and it comes with the wires, but then they're all individual wires. So you can be I don't need these. I only need 24 pin, the 8 pin, and I need 2 more of these, and I don't need any of these. So I can just leave all those wires out, which makes your computer much nicer to look at, less wires running all over the place for you to hide, those types of things. All right. You have the semi-modular one, which is to the right here, which has the 24 pin plugged in, but every other one not hardwired. And that's because, well, we know you're going to need a 24 pin. There's no option. You need to have this 24 pin, so why leave it modular? And the answer is, if you leave it as modular, that means you can get custom cables made. Again, keep your builds looking nicer. So, I don't know. Semi-modular seems good enough to me. And then non-modular is down here at the bottom, and you can see that we have all of the different cables just sticking off the cable out all the time. So even though you might not need all of these different plugs that we have going on down there, those are all just going to be hanging out in your case somewhere somehow. All right. So kind of an interesting thing. But otherwise, if it's a 750 gold, and they're all 750 golds, they all should have the same overall power output capabilities. All right, and then if you are ever interested in building your own PC, there's a great website called PC Part Picker. All right, and this shows you, so you can actually build your own computer. Build in quotes, right? So you can kind of assemble a computer on here and have it say, yes, this motherboard is going to work with that. This is going to work with that. This which is going to work with that. All right. Here is the great AMD gaming build. All right. And this was the goal was about $1,000. We look down here, GPU RX 6600. So they came out to $826 right now currently. All right. So it's just kind of interesting to be able to look at all these different things and everything going on. And it's a great place for you can start. So you can go with Builder, and you can say I want to use, and then you can go pick your CPU that you want to use, and you could sort by brand, and you can go by price, and you can say, okay, let's say I'm going to use this one. And let me hit buy. I'll buy a button. There it is, add to parts list. So now I have that. So now when I go to the CPU cooler, now it knows that it has to be compatible with that CPU that I'm using. So I can say, okay, let's use that one. And now I go to my motherboard. Again, it's knowing that it has to be able to fit that CPU and that cooler. So it's only giving me options. All right, so I could say, yep, give me that one. And then same thing with memory. All right. These are DDR5, so the CPU I'm using is DDR5, so nothing here should be DDR4. All right. So again, it's very much limiting me down to very specific things, which is very helpful for you to make sure that you are building a computer that is going to work. And a long time ago, my computer I built back in 2018, this is what I did to actually put it all together to make sure it was going to work. And as you hopefully saw, you also have the option to set price alerts for things. So you can be like, I want to use this one, and you can say like, send me an email if the price drops below this magic number. All right, which it does look like it happened every once in a while. Here, Walmart had it for just over $1,000 right now. Where right now it's $1,150. All right, so it's really a really nice website if you want to try and build your own computer. It is not the end-all be-all. It's not the perfect answer, but it is definitely a nice place to start if you're interested. And again, this can all just be a fantasy, right? You can be like, I want to build this computer, and you can just like put all the parts together and see what it's going to cost you. So, all right, that is all that I've got for Chapter 2.